Uh, Thanks for having me. And it will be challenging for me to keep all of you awake for another 30-35 minutes. I hope I will do a better job. Uh, so we are going to talk about expand contract pattern, a pattern that can be used for continuous delivery of databases. So before I start, just to get an idea of the audience, can you raise your hands if you are a programmer who write code regularly? Keep your hands up if you are handling databases also. Okay, so good enough crowd. I hope you will take away something at the end of the session. So I am, like he mentioned in the introduction, I am building this product called Good Karma. It's a digital marketing product for wellness space. And if you've worked with products, one of the key challenges is the iterations. Are there too much noise? I mean, I can hear a lot of interruption. It's okay? Okay. So iterations in the sense we go with an idea to the market, then when we release it, we realize, okay, this is not what the people want. We change it, right? So that iteration continues, and I don't think any product stops with that iteration, and that's the power of product also. And if you're not innovating in your product, I don't think people will continue using it. Okay, but the challenge with that is the evolvability. That is, you keep evolving your product. So this anecdote, I think, makes a lot of sense. In the book, Building Evolutionary Architecture, they give a comparison to the people in the circus who run unicycle, and they also throw balls to the top and try to catch it, right? So when you have a product in production, you are trying to evolve it while you are making sure that nothing is broken in the production. Okay, so how do you keep that balance? That's very challenging. And let's look at some of the examples to make it more clear. I hope everyone is aware of eBay. eBay is one of the very early product who brought in marketplace as a concept to the internet. eBay had gone through, I think they started somewhere around 95 or something. They have gone through 4 or 5 major architecture change, tech stack change in the application over I think the next 10 or 12 years. Okay, and they started off with as a Perl script that was got into production over a weekend. That actually served for a long time for them. Then they changed to an MVC architecture, I think in PHP. Then later they changed to Java stack. Okay, and I'm not sure what is it now, but they've gone through major changes in their architecture in the 10-12 years of after building it, and all these changes happened without bringing the production down even for a day. So customers never realized that these big changes are happening. Okay, and that's amazing because considering the scale of eBay, they cannot afford to have a downtime, and then they made bigger changes to the application without even bringing it down. And that's so. In this article, Martifolo talks about it as sacrificial architecture. You sacrifice your earlier architecture as you grow, right? Because of scaling or because of new requirements in the product. Okay. Another example that I would like to bring in, these are examples to bring in like what is the complexity of evolvement, right? Evolvement as a scale of the product increases, or evolvement as a product takes to new areas as features, okay? So another example is, I'm sure all of you have used GitHub. One of the things that GitHub as an innovation they brought in is the PR pull request model, right? You can check in something, you can see what exact change has gone into that revision. A good comparison of what has changed. That way you can compare it and then make sure that, especially for a code review, it was very, very useful, right? And similar to eBay's case, when they started off, GitHub had this again mentioned in this article. They had a script to do the comparison. The standard Git merge had some issues, so they wrote another way. They had another way of doing the merge, which is more useful to show it in the UI. And it was a script that they were using. As the scale of GitHub increased, they realized that this is not going to be scalable. Running a script which creates a lot of temporary files and other things was creating an issue for them. And they had to move to a new implementation. But that's very, it's not just a switch, right? Because they have to make sure that the correctness of the comparison was very accurate in the current implementation, that they cannot afford to change when they move to a new implementation. Okay, so what they did was, it's not like they can just release the new library and then see what happens, because it will be very costly for GitHub if something breaks, right? Considering that this is one of the key differentiator that GitHub has brought into the market, right? So what they did was they implemented the new library, okay, but that was, and released to production, but it was not visible to the user. It still used the old implementation for showing the difference in the UI, but parallelly they also ran the old library, and the engineering team actually started comparing the results between the old implementation and the new implementation, and they found differences, accuracy differences, and then they tuned it for a few days. Considering the scale of GitHub, running it for 2-3 days has given them enough data to confirm that, okay, this is good enough. And then once they were comfortable that, okay, this new library is as good as the earlier one, they switched it, okay? And they killed the earlier implementation of the script. Okay, so this also shows up like how can you make bigger changes to the application, to the crux of the application in a manner which is not costly to the product, right? And similar to that, another example is how GitHub upgraded Rails. Till recently, I think even 1 year back, they were using a pretty old version of Rails, and it's a 10-year-old code base, and it took almost 1.5 years for them to actually upgrade to the latest version of Rails. But what they did was they didn't upgrade as a one big bang release. What they did was they changed some part of the code to use the latest version. They have multiple applications within that major application, and then they upgraded part by part, and then the entire upgrade took almost 1.5 years. Okay, so these examples I'm bringing in to show that, okay, how major products like GitHub or say eBay is continually changing the technology or their architecture to support the newer requirements. Okay, so, but the techniques that they used was they didn't do a big bang change. They did things in step-by-step fashion. Okay, so and that was very safer for them, because even if something goes wrong, they know that exactly what changed. If you're making a lot of change, a series of change and pushing it to production at once, and something breaks, then it will be difficult for you to identify what exactly caused the issue. Okay, so doing it incrementally is giving them the benefit of quickly reacting to the issues, right? Because exactly what has changed, they know, and what is a fix for that also is either they can quickly roll back, or they can do a quick fix and then deploy it again. Okay, and then all of them had parallel implementation, even though it doesn't make, it makes the code a little bigger. Like you have the old implementation as well as the new implementation. In case of Rails upgradation for GitHub, they had multiple versions of Rails running in production for long. But that gave them the benefit of making sure that, okay, they do it in a safer manner. Similar case with the merge library. They used both the libraries at the same time. But that's okay. That's how they leverage the power of deployments. Okay, and the techniques that they used, these are not something new. In the software engineering side, there are patterns that was established to support these kind of things. One of the pattern is called branch by abstraction. Okay, branch by abstraction is rather than having multiple branches in the version control. You abstract it out in your code. Okay, so you want to change a major library, or you want to move from one framework to another. Instead of changing entire application at once, what you can do is you can use both the frameworks at the same time, and then move part by part into the newer implementation or a period, and then completely get rid of the old framework, say after a few months or few years, depending upon how much complex your application is. Okay, and that's a known technique for making major changes to your application. And this gives you the confidence, because you can push the changes to the production and see what happens, rather than working on it in a vacuum for so long, and one fine day you push it to production and see, okay, something is breaking. Okay, then it is difficult for you to go back. Okay, and another pattern is Stranger pattern. This is very common in the microservice world. If you are killing your monolith app and creating a multiple microservices, what you use is this pattern. You have your router level. You redirect to the newer applications depending upon you build what is the new application that you have built. And in case there is a problem, you can quickly switch back, because it's a change in the router. No, the entire application has to change. Okay, so these are the patterns that is very useful when you're making major architecture change or major change to your crux of your application. Okay, and the base fundamental to this is, again, going back to the software engineering, is refactoring. You do small changes. Refactoring is not big bang. If you really got a lot of value from refactoring, then you should do it in small steps. You do a lot of small changes to your application, and at the end of a series of steps, you get a bigger change. And that's the power of refactoring, and that's what happens when you are doing parallel implementation also. You do a lot of small changes, and at the end of a series of small changes, you get a bigger change. Okay, and it allows continuous delivery. As and when you are making small change, you can push it to production. You don't have to wait for anything. Okay, it's not like you have to make the entire change to the application to push it to production. Okay, but the question comes up: can you do similar thing for a database? Okay, can you make major schema changes to the database in a continuous delivery and evolutionary manner? How can you achieve evolutionary database? Okay, as in when the application changes, or when you are adding, when you realize that, okay, you have to change the way you have implemented things, how can you make sure that the database also support continuous delivery? And the rest of the talk is about focusing on that. And there is a technique called database refactoring. This book, the techniques that I'm mentioning in the talk is from the book called Refactoring Databases, which was actually released soon after the refactoring book came out a long time back. But I don't think it has got enough attention at that point of time. It is getting attention now when DevOps and continuous delivery, all those things are becoming mainstream now. Okay, so a lot of techniques that is mentioned over here is applicable today also, maybe more relevant today than maybe when it was released. It enables continuous delivery and supports evolutionary development. I've been talking a lot of theory now. Let's look at some examples. These examples are something that I had actually implemented in my product. These are not just some cooked up examples. I've tailored it, made it simple so that you can understand it better. But these are real examples. So I am talking from my experience. It's not just a theory talk. Okay. So I have been doing this for years now, and so I just wanted to share it with more and more people. So there is a technique called split column refactoring. Let's look at it as an example. So our product is also a CRM, a customer relations management for the wellness industry. So it is usually used by yoga centers or say gym centers. Right now our target is India. So across India we have customers, mostly yoga centers. So what happens is people can book a trial class using an IVR system that we set up for them. Using the number given in the IVR, they can book a trial class with the center. Okay, but and that is tracked in the application as trial bookings. What happens is that, okay, many a times, not everyone who books a trial turns up. Okay, and those who turn up for the trial, they may or may not register with the sender. They just turn up for the trial class and then they may not come back. Okay, so all this data we are tracking in the system, in the field status. Okay, so who booked the trial, when did they book the trial, and what is the status of that trial? Did they actually turn up for the trial? And if they have turned up, whether they have become a registered member. Or some turns up, they don't register. Some may not turn up for the trial itself. Okay, but those who may not turn up for the trial, but they may register later, even without having a trial. So the status field contains a lot of information about that member. Okay, like whether they attended and registered, attended, not registered. So these are status numbers that we have given there. Then we realize that, okay, this is an overloaded field. We need to split it into multiple columns. Okay, because like if a function, if you're writing a function and then if that function is doing too many things, it's better to split it into smaller functions to make it more intuitive, and make it more reusable, maybe further down. Okay, so we had to split this, and we split it into attendance status and membership status to make it clear, okay, what is this status about. Okay, so if you're doing it in the database refactoring way, actually we don't need the status field anymore because we are migrating the data into two different fields. So but instead of deleting that data at the same time, so we need to add the new field. We need to migrate the data from existing field to the new fields, and then we should delete the old field so that no one uses it further down the line. Instead of doing all these steps at once, what we did was took the parallel implementation way. That is what is actually recommended in the database refactoring way. Okay, so we have the new fields as well as the old field. The one marked in green are the new ones. Red is about to be deleted. And during this, we also when we are running, when we deploy the new change, we have to also make sure that we are getting the data from the existing fields and migrating it to the new fields. Okay, so we wrote scripts to do that. Okay, also made sure that the data is continuously syncing. When something gets added to the status field, it has to be reflected on the newer fields. So we just changed this and then released it to the production. Okay, even before making any change to the application to start using the new field. Okay, so what this gave us was to make sure that the data is reflecting the newer fields and that it is actually added to the newer field. And while you're making the changes to the application to start using the new fields, the changes are already in the production. Okay, and during the transition period, this is what it will look like. Just the numbers doesn't make much sense. It's just the number says, okay, if it is 0, they have not attended. If it is 1, they have attended, like that. Okay. And once we actually change the entire application to use the new field, we contracted it. That is, we got rid of the old field because we don't need that anymore. So the advantage with this approach is that, especially when you have a lot of downstream dependencies, say mobile apps or other applications using your database, right? That it gives those applications enough time to actually migrate to the new implementation. Okay, rather than just doing it on one day and saying that, okay, this field doesn't exist anymore, and then it may break other applications. Okay, so and this is the entire refactoring process. You start with the old schema. You have a transition period where we have both the implementation, and after a while you contract to the new implementation. Okay, and this is a technique when you are actually changing, splitting a column into multiple columns. This is a technique that you can use. It's called split column refactoring. Let's look at another example. It's a split table. That is when you are splitting one table to multiple. So in this example, once a customer becomes a member, they start taking packages with the sender. Okay, and those we are calling them as billing cycles. And so this is the schema that we had, like who paid on what date and what is the amount they paid. Then later we realized that, okay, people pay in installments. So for a single cycle, instead of paying if it is a 1 year cycle, instead of paying the entire amount upfront, they may pay for 6 months, and then after 6 months they pay the rest of the amount. So such a case where one cycle having multiple payments, that cannot be tracked with this. So we had to split this into a one-to-many relation. Okay, and so when we split that, we didn't delete the earlier fields. We continued to retain that while adding the new table. And we made sure that the data whatever data we have on the old table is also migrated to the new table. When we release a migration script, when we added the new field, we also release a migration script to port the data. And then it will continue to sync. Whenever a new billing cycle is added, the data is parallelly added to the payments table also. And during the transition period, the same data is stored across both the tables. Okay. And at the end of, so once we implemented the partial payment functionality into the application, then we remove the unnecessary columns, and then deleted the earlier one. And we can safely delete it because we already have the data in the new table. Okay, and this is the transition period this is the entire refactoring in steps. Okay, so and this is the pattern called expand contract pattern. Okay, so what you're doing is you are expanding to the new implementation, and then you have a transition period where you have both newer and older implementation, and then you're contracting to the new implementation. And that time period actually allows you to monitor and observe and make sure that, okay, the schema change, it hasn't affected anything else. Okay, this is a very safe way of releasing, especially when you are making changes to crux of the application. This is a recommended way of doing it. Okay, and there are different kinds of refactoring. I'm not going to touch upon everything. For some of them, how can you create a view on top of a table, or how can you convert a view into a table, right? So so and so forth. All kinds of database changes are mentioned in the book, and then not for everything the expand contract pattern makes sense, but for some it makes sense. Okay. So what are the basics that is required to support this? One is that every database change has to be there in the version control. It has to be like your code. It cannot just go to the production and make changes. It has to go via the version control system, and every script, every database change script has to be uniquely identifiable. Okay, so that you know what version of the database is existing at each environment. Okay, that you should be able to know. And for a unique identifier of the script, you can use multiple strategies, like you can use a bill number or a timestamp or a unique identifier. That either depends on what is your preference, or depends on the tool that you're using for database migrations. Okay, and you need a lot of automation, unit testing especially, and integration tests to make sure that, okay, the changes are indeed safer. Okay, so that you can catch it much before going into production. You need automation to make sure that during the deployment, all the database changes are also deployed as part of the run as part of the deployment. And in case the database changes are failed, then it has to be reverted. The entire code has to be reverted back. The change should not go, and it has to be considered as a code change, similar to code change. Okay, and main thing is about the strategy, that is how long your transition period should be, right? We don't want a case where you have both the old implementation and new implementation, and that goes forever, right? Because it's an unnecessary code that you keep in the repository, and then any code is a technical debt, especially if it is unused code. it becomes more debt. Okay, so there should be, as a team, you have to decide, okay, what is a good transition period that you should have. Okay, and this is one place as a team you have to be disciplined enough to make sure that the contract actually happens, not just the expand. Okay, there are some tools. So I think most of the ORMs comes with support for migrations. So I've been using Ruby on Rails for a long time, and it implements active record pattern, and it has support for database migration within it, and it has the intelligence to know, okay, when you generate a migration script, it gives a unique identifier, and then what is the version that you are running on an environment. All these are part of the ORM itself, but I found that there are other tools which you can add to your application to support this, especially in the Java world. I think Liquibase is very, very common. I have not used it a lot, but I've tried it in the past, and it seems to be very reliable. So just to summarize, things will always go wrong. You have to be optimistic that it will work, but you should also think what happens when it goes wrong, right? And then most of the time you see more failures than expected, right? And when failures happen, you need to make sure that first and foremost, you should know when the failure happens quickly, even before your customers find it. And you should be able to fix it quickly without having a lot of downtime. Okay, so the only way to make sure that that your releases are safer, you need to reduce the risk. Okay, and the way to reduce the risk is by releasing often. If something is painful, you get that pain by doing it more often, right? Not by running away from that pain. Okay, so if deployments are failure, do it all the time, but in small chunks. If you have to do a lot of releases, you can't have big bang changes all the time. You need to have smaller releases. Okay, and have enough systems to let you know when something goes wrong. Add up that metrics, or say observe the lot of monitoring system, lot of tests to make sure that, okay, things are actually safer. And these are the books that I use. These books, the entire talk is a summary of all these books. There are a lot more in these books. I highly recommend you, if you really want to implement continuous delivery, all these books are very useful. And some of the references I've used. And that's it. You can reach me. I usually rant in Medium, so you can follow me if you like my talk. So. And we have time for questions, I think. If you still have energy after lunch, you can throw some questions to me. So when there are no questions, it talks two things. Either you got everything, which is very difficult to believe, okay, or you didn't get anything. So.
Hi.
Hi.
So you spoke about changing the contracts on a split column or split table wise. So let's say on a given scenario, you do have a client. I mean, if it's a web-based client, you do have a control of the contracts with the API. But then again, let's say if you have a mobile client which are user side dependent, the updates and so on, how would you change that contract changes with the database layer?
So that's a good question. That is the transition period that we are talking about. So how long you want to keep that migration, because you don't have a much control on updation of the mobile app. So one is you can do two things there. One is that you can still contract, and then but give this data as a you can delete it from the database, but you can give this data just to support the deprecated applications. That's one way of doing it. So you can give some, so if in our example, you know that, okay, if these two status is this value, then this will be the status value. So you put that into code and then release it. That is one way of doing it. But again, you are still referring to the column. That may not be a great idea. Second is, you can actually, after beyond this period, we are not going to put a hard stop on that support beyond this period. Like that is what API deprecation does, right? Beyond, if you're using a very old version of your API, that is no longer supported, right? And then you're forced to make updates to your API, right? So that hard stop is much better. And you can put enough analytics to see how many users are there in this thing, and then you can see in that way, you know what is the cost of really putting a hard stop on this. Most of the cases it will be very, very few. So if you put such a hard stop, there is a higher chance that users might upgrade. Okay, recommend the second way because that is when you are actually contracting. But if you can't do that, maybe the first way is another way to do it. Okay. Any other questions? Okay, so I'll be around. If you still have questions, you can come and talk to me. Okay. Thank you.